How to balance DAC resolution, speed, and power. Imagine trying to get the perfect sound or signal output from a device. To do that, you need to balance three key things in a digital to analog converter. These are resolution, speed, and power. Each one impacts how well your system performs. Improving one often makes the others harder to achieve. So, understanding how they work together is essential for designing effective electronics. Let's start with resolution. This is how many voltage levels your DAC can produce. The more levels, the finer the detail in your output. For example, a 16-bit DAC can produce over 65,000 levels, giving very smooth signals. But higher resolution means more complex circuitry and more power needed to operate those extra components. It also takes longer to settle to the correct voltage, which can slow things down. Next is speed. This is how many times per second the DAC can change its output. High-speed DACs are necessary for applications like radio signals or waveform generation. But increasing speed can introduce more noise and requires faster, more expensive components. It also demands a better clocking system and more power to handle rapid changes. Power consumption is the third factor. When a DAC has high resolution and high speed, it uses more power because more internal parts switch and work harder. This is a big concern in portable or battery-powered devices. To save power, designers might lower resolution or speed, but that can reduce signal quality or responsiveness. Balancing these three involves trade-offs. For example, if you need high resolution for detailed audio, you might accept slower update rates and higher power use. If you need quick signals, you might settle for lower resolution to keep power and noise manageable. High-speed DACs often sacrifice some resolution to maintain their speed without consuming too much power. There are techniques to help find a good middle ground. Interpolating DACs oversample input data, allowing slower data rates but still producing high output speed and resolution. Proper filtering and output stage design can improve settling times and reduce noise, helping to balance speed and accuracy. Adjusting bandwidth and settling time ensures the output reaches the desired voltage quickly without excessive noise. Managing noise is also key. Reducing noise sources like broadband noise and flicker noise allows the DAC to operate faster and more accurately. Good layout, shielding, and component choices all help keep noise levels low. In real-world applications, these balances are vital. For instance, in software-defined radios, DACs need high resolution and decent speed to accurately generate signals. In complex waveform generators, very high-speed DACs use advanced architectures and filtering to produce clean signals while managing power and complexity. Ultimately, choosing the right balance depends on what your project needs most. Whether it's high resolution, fast response, or low power, understanding these trade-offs helps you pick the best DAC for your system. Techniques like interpolation, filtering, and bandwidth control are your tools to achieve that perfect compromise.